So we're going to talk about the dot product. So the dot product of two vectors. So if I have a vector u, a, b, and then another vector v, c, d. So the dot product is found, so normally we think of this as multiplication, but we read this now as u dot v. And I want you to notice how the multiplication is structured. A times c plus b times d. So you have to use a dot with the dot product. You can't use a star. You can't use an X. It's the dot product. You need a dot. So we will talk more about this in this video. Another name for the dot product, by the way, is inner product. And the dot product will result in a real number, not a vector. So look at this. Look again at the result. A times C plus B times D. So A, C, B, and D are all numbers, right? And I'm just adding them up together. The vector notation is gone. So the dot product will result in a real number. So it's pretty simple to calculate. So I've got 3, 5, and 2, -1. So I want to find the dot product between these. So I take 3 times 2 plus 5 times -1. Just add them up, no problem, right? So I remember when I first learned the dot product, and I just thought it was like, it seemed very simple. It is a very simple concept, but it also seemed a little weird because it's like you don't normally think that you can do an operation with vectors or something, right? And then you just end up with like a different form. I don't know. So it is this simple, but and like I said, we're going to go through more of like the meanings of everything. Why don't you try this one just to make sure you've got it and then hit play when you're ready. So I've got 2 times -4 and -3 times -5. So that's -8 plus 15. So that's just going to equal 7. So that's the dot product. Okay, so the dot product has a bunch of different properties. So I've got them listed here. So the dot product is commutative. So u times v is the same as v times u. It has kind of this like pseudo distributive property. So if I take u and dot it with, so keep this straight now, u and dot this with the vector that is v plus w. This by itself would be a vector, and then I dot it with u. This will no longer be a vector, and instead what we'll do is u dot v plus u dot w. And then this is no longer a vector. And the same thing can be said if I take u plus v dot w. If I have a scalar, it doesn't matter where you multiply the scalar. So if I take k times u and then I dot that with v, that's the same as just taking u dot v and then multiplying it by k. Or I could multiply k times the second vector and then dot it. It's all the same. I had a little error on number 5. So if I take the 0 vector and dot it with u, I will get just 0. And so you could probably see why I made that notation error. It's just you get yeah. So the 0 vector dotted with u will just equal 0, not the vector. And then u dotted with itself will give me the magnitude of u squared. Okay, so let's try now a few of these operations, playing around with this a little bit. So let's say that I've got u dot v minus u dot w. Okay, so I'm going to take u dot v, so it's going to be 1 times 2 plus 3 times 4, and then I'll subtract off u dot w. So it's going to be 1 times -1 and 3 times 2. So here's all the operations that I need to do. Go ahead and multiply everything together. So what I'm left with is 14 minus 5, and so this will equal 9. Okay, so I would actually recommend that you try this one on your own and hit play when you're ready. So I need to take the scalar 3 and multiply it times the vector u. So first if I do that, so 3 times u, so I take 3 times 1, which is 3, 3 times 3, which is 9, and now I dot this with the w vector, and then I can take the dot product as you see here, so ultimately I get 15. So the dot product, just to be clear, it can be positive, it can be negative, it can be 0. So don't freak out if you get any one of those results. And so now you're probably like, okay, I'm calculating this. What does this mean? So the dot product has a geometric interpretation. It has a relationship with an angle theta. So here is like how we can describe that relationship. So if you have two vectors, you can actually figure out the angle between them by using the dot product and their magnitudes. So put another way, we could think of the dot product as the two magnitudes times the angle between the two vectors. Now, in a sketch, I can just show you kind of what this is getting at. There is an entire proof to show why this works, though I'm going to omit this for now just to keep this video shorter. Though if I get any requests to show that proof, I love making proof videos, so I would happily make it. You can just leave me a comment if you're interested in seeing that. Okay, so let's just work on finding the angle between the vectors. So I've got two random vectors here. So you can take this formula and then you kind of just go through and you find all the numerical pieces of it. So if I take u dot v, it's going to be 1 times 2 plus 3 times 4, so that's going to be 14. Then I have to find the magnitude of u, so I take 1 squared plus 3 squared and get 10. And then I take the magnitude of v, and that's going to be 2 squared plus 4 squared, and that's going to equal 20. Okay. So then I can just plug all those pieces in, right? So 14 divided by the square root of 10 times the square root of 20. Now, if you are entering this in verbatim into your calculator, I probably should just mention that when you enter this in, don't make the rookie mistake of forgetting the parentheses on the denominator. Otherwise, your calculator will misinterpret that. So just a heads up there. And so if you do that, you get cosine of theta equals 0.99. So then I take inverse cosine to get that the angle will be 8.13. Okay, let's move on to another example. Why don't you try this one on your own? Again, just try to find the angle between the two vectors. Give it a go. Hit play when you're ready. Okay, so once again, I'm going to use this formula here. So I've just got all my work here. So here's the dot product. So the dot product between them was 5. The magnitude of u was the square root of 5, and the magnitude of v was the square root of 10. So if I plug all of that good stuff in, I will get 0.707. And so if I take the inverse cosine of that, I got 45 degrees. Okay, so we can generalize the results of the dot product. So if the dot product is positive, then we know that the angle between the vectors is acute. If it's negative, then we know that the angle between the vectors is obtuse. And if the dot product equals 0, then we know that we have a right angle. So just to reiterate that, when the dot product is 0, you know right away that theta equals 90. And you also know, since theta is equal to 90, the vectors must be perpendicular. Or my favorite math word, because yes, you know I have one, orthogonal. Say it with me, even if you're sitting at home alone. In fact, say it even if you're at a cafe. Orthogonal. I don't know, I just really like that word for some reason. I just think it's like it just makes you sound so cool. It's fun to say. Say it around your friends. Say it at parties. That's definitely what I do. Okay, so I'm sorry. All right, so let's determine if the vectors are orthogonal. So all you have to do is find the dot product between them. So why don't you pause the video here and try that. All right, so here I am dotting it up, and I've got negative 6 plus 6. Oh, that equals 0. So what does that mean? Orthogonal. Okay, so that's all my octaves of singing orthogonal for you in this video. Please leave this video a like or a comment. Consider subscribing to the channel. And thanks for watching, guys. I will catch you in another video.